Mathematics. The figure below is that of a cone ABC from which a vuvuzela DBCE was made by cutting of its sharp end as shown. So take pi to be 3.142. So a cone ABC. So this is a cone. And then a vuvuzela DBCE was made by cutting of this sharp end. So we have given that AF is 30 centimeters, AF is 30 centimeters, GF is 25 centimeters, DG, that is the radius of the small cone which was cut off, 1 centimeter, and AD, which is the slant length, is 4.9. So calculate the curved surface area of the piece that was cut off. So the piece that was cut off, this was the part which was cut off. So we have AD, which is the slant length, it is 4.9 centimeters. So that is the slant length. So the question is, calculate the curved surface area of the piece that was cut off. So this is the piece which was cut off. So we have DG. So this is G. So DG, which is also EG, it's the same because it's radius. So DG, it is 1 centimeter. So this shape, it is the shape of a cone. So how do we calculate the curved surface area of the cone? So the formula is given by So that is the formula of a curved surface area. So curved surface area is equal to pi times radius times the slant length. So we have pi is 3.142 times radius. So the radius is 1. So dg, it is 1. So which is the same as GE. So dg, it is 1 centimeter. That is our radius. Times the slant length. The slant length, it is 4.9. So the curved surface area is equal to 15.4 centimeters squared. So this is our final answer. So that is our answer, the curved surface area. So part 2, calculate the volume of the vuvuzela. So the vuvuzela, it is D, B, C, E. That is the vuvuzela. So this vuvuzela, it is in the shape of a frustum. It is in the shape of a frustum. So how do we calculate the volume of the frustum? In this case, which is the vuvuzela. So we are going to calculate the volume of the O cone before this sharp end was cut off. So the volume of the O shape minus the volume of the part which was cut off. Then we are going to remain with the frustum. How do we calculate now the volume of the vuvuzela, which is the frustum? So this is the frustum. So now I'll say volume of the vuvuzela is equal to 1/3 pi r squared times height minus 1 over 3 by r squared h. So now, the first part I'm using the capital letters to show the radius and the height of a big cone before the sharp end was cut off. Then the small radius and h, it is showing the radius and the height of a small cone which was cut off. Okay, so volume is equal to 1 over 3 times pi times radius. So radius, it's a radius of the big cone. So radius is the radius of the big cone, which is BF. So do we have BF from the question? No, from the question, we don't have BF. So we are going to find BF. So how do we find BF? We are going to find BF by using what we are calling ratios. So let's find BF. So we'll say BF, which is the radius of the big cone, divided by DG. DG. So DG, it is the radius of the small cone, which was cut off, is equal to, what have I been given? I've been given the heights. So I'll say height of the big cone divided by height of the small cone. So BF over DG, it is 1, equals big height, which is AF. AF is 30 over the small height, which is AG. So AG, it is simply 5. So 1 into BF, that is BF. So 5 into 30, that is 6. So 6 centimeters. That is our BF. Okay, so BF, it is 6. So BF, it is 6, so it will be 6 squared. Then the big height, it is 30, so it will be times 30 minus 1 over 3 pi times small radius, which is DG, it is 1. So it will be 1 squared times small height, which is AG, which is 5. So volume is equal to 1 over 3 times pi times 6 squared times 30. The answer is 1130.97 minus 1 over 3 times pi times 1 squared times 5. The answer is 5.24. So volume is equal to, when I subtract, I have 1125.73. So remember that your answer should be in 3 significant figures. So volume is equal to 1, 2, 3. The neighboring number is more than 4, so I'll add the 1 there. It will be 1, 1, 3. This means 0. So centimeters cubic. So this is the volume of the vuvuzela.